Hello students. So in this video we'll continue with the chapter 10 Gravitation of ninth class NCERT textbook. Now you have studied in the previous lecture, in the previous video, what is weight of a body. What do you mean by weight of a body? We have defined it as the force with which earth attracts the body towards itself. So when we say weight of a body, we always consider its weight on the surface of earth, or the body is lying on the surface of earth, or the body is lying close to the surface of earth. So in that case, when we drop a body, we know that body falls vertically downwards because of gravity of earth. So we generally define weight as the force with which the earth attracts a body towards itself. But remember, if you are on the moon surface, or if you are lying close to the moon surface, and then if you drop any body, that is not going to fall towards earth. There it is going to fall towards moon, because gravitational pull of moon is more dominant than the gravitational pull of earth for that body which is lying closer to moon. So students, remember, weight of a body, we consider it always to be due to gravity of earth, but it depends. If the body is lying on moon, then we can define weight of a body on moon as the force with which the moon attracts a body towards its center. So it's not always the gravitational pull of earth. If the body is lying closer to moon, then weight of a body on moon we consider, and it is a force with which moon attracts a body towards its center. So now if I ask you what is weight of a body on earth, you can say it is a force with which earth attracts a body towards its center. Let us compare the two weights. Let us consider the same body. First it is lying, if we take it on the surface of earth and then near the surface of moon, then let us check how the weights vary. Because the forces with which the earth and moon attracts the same body will change. As mass of moon, mass of earth, they are different. Radius of moon, radius of earth are different. So the weights of the body will also be different on moon and earth. So let us see the comparison between weight of a body on moon and the same weight of the same body on earth. So let us consider small m is mass of the body, capital M is mass of moon, and capital mm is mass of moon, and me is mass of earth. Let Rm be radius of moon and Re be radius of earth. I have written them together so that I can use less space. Okay. So this is an introduction. In introduction you have to mention that M is the mass of body. You have to mention about masses of moon and earth, radii of moon and earth. Now we know by definition it is the force. Which force? Gravitational force with which moon attracts a body towards its center. So we can use always Newton's universal law of gravitation to write an expression for weight of a body on earth and weight of a body on moon. So according to Newton's universal law of gravitation, you are required to mention this, otherwise you can lose marks. Weight of a body on moon, we can represent it by Wm, is equal to, use the universal law of gravitation's mathematical expression. We know it is capital G, product of masses of the two bodies. Here weight of a body on moon, which are the two bodies? One is this body having mass small m, second is mass of the moon. So capital G into into m divided by is distance between their centers, that we have to take it as now radius of moon, because we will consider that body is point object compared to moon. So divided by Rm square. Number this equation as 1. Similar way we can write weight of a body on earth, which we can represent by We, is equal to capital G Me into m upon Re square. So number this equation as 2. So we have written two expressions, one for weight of a body on moon and the other for weight of a body on earth by using Newton's universal law of gravitation. For this derivation, you are required to define weight of a body on moon. You can also define weight of a body on earth here. Okay, define the two weights, write the introduction, and then using this, write these two expressions. Now let us divide 1 by 2. Let us divide this equation 1 by 2. So what do we get? Wm divided by We is equal to, write this, capital G mm into m upon Rm square divided by capital G me into m upon Re square. And when you simplify this, it becomes this numerator gmm into m upon Rm square into reciprocal of this, which is Re square upon Gme into m. Now you know that G is common in numerator and denominator, so it will get cancelled. Small m will get cancelled. And we are left with Wm upon We is equal to mm into Re square divided by Rm square into Me. So if you are given the values of, if you know the values of masses of moon and earth and their radii, if you know their values, there is no need to by heart the values. If somewhere in the paper it is given, fine, otherwise you can simply write. Putting the values of mass of moon and mass of earth, radius of moon and radius of earth, we get Wm upon We is approximately equal to 1 upon 6. So I have not shown here the substitution. Even if the numbers are not given, no need to by heart. You can just write one sentence here that substituting the values for mass of moon, mass of earth, radius of moon and radius of earth, Wm upon We is approximately equal to 1 by 6. So from this we get that weight of a body on moon is approximately equal to, this is a sign for approximately equal to 1 by 6 into weight of a body on earth. So remember, weight of a body on moon is always 1 by 6 times weight of a body on earth. Now think, if I ask you a question, what is your weight on earth? What would be your answer? I am sure 90% of the students will give wrong answer, because you will say my weight is 60 kg, 50 kg. But you know that kg is a unit for mass, not weight. Okay, so let us see what is the confusion here, and let us clear that confusion regarding the units of weight. Now students, if you are asked, state the SI unit of force, you know the answer. Answer would be Newton. CGS unit of force, dyne. And so SI unit of, as weight is also force only, a kind of force. So your answer would be same for weight also, that SI unit of weight is Newton and its CGS unit is dyne. But students, remember that SI unit, that is Newton, and CGS unit dyne, these are the absolute units of force or weight, we can say. Actually, when we talk about the units of weight, or we can say units of force, there are two kinds of units. Generally, we talk about absolute units. You know that the absolute unit, SI unit is Newton, and absolute CGS unit of force or weight is dyne. But let us see the other type of units of weight or force here. There are two types of units. One is absolute units, which you are already familiar with. Second is gravitational units. So SI, gravitational SI unit of weight is kg weight or kg force. And gravitational CGS unit of weight, or we can say force, is gram weight or gram force. So first learn here the names. Kg weight, that is kilogram weight or kilogram force. CGS unit is gram weight or gram force. Now let us see their definition. Just recall, what is Newton? To define Newton, we have used the expression from Newton's second law of motion. Mathematical form of Newton's second law of motion states that it is F is equal to ma, where F is a force acting on a body having mass m and producing acceleration a in that body. So using this expression, we can define easily Newton and dyne. We can easily define the absolute units by using Newton's second law of motion. See, for the definition of Newton, we usually take this is 1 Newton when mass of a body is 1 kg and acceleration produced is 1 meter per second square. You know the definition of Newton. 1 Newton is a force which when acts on a body of mass 1 kg produces an acceleration of 1 meter per second square in it. And hence from the definition, when we put this each value to be equal to 1, we get 1 Newton is 1 kg meter per second square. Similarly, we have earlier also defined the CGS unit of force, that is dyne. Again, by using the same F is equal to ma, when we take mass to be 1 gram and acceleration to be 1 centimeter per second square, we get the force is 1 dyne. So, you know the definition of dyne. 1 dyne is a force which when acts on a body of mass 1 gram produces an acceleration of 1 centimeter per second square in it. And by using the definition, when we put each value to be equal to 1, we get 1 dyne is equal to 1 gram centimeter per second square. So these absolute units, their definition, their conversion, we have studied earlier in one of the earlier videos. You know that we can convert 1 Newton into dynes. We can show the conversion and 1 Newton is equal to 10 raised to 5 times. Now, absolute units you already know. Let us see what are the gravitational units. Now, as I have told you that kg weight is a gravitational SI unit and gram weight or gram force is a CGS gravitational unit or gravitational CGS unit of force or weight. Now, let us see their definition. To define them, we are not going to use this expression F is equal to ma. As the name itself suggests, gravitational unit. So what we'll do, we'll use the same formula, but instead of A, we will take G. You remember what is G? G is acceleration due to gravity. So F is equal to mg, it means F is a force acting on any body having mass m which produces an acceleration a in it. But here when we say F is equal to mg, we know that F is a force of gravity acting on a body having mass m. Okay, and generally we consider the body to be lying close to the surface of earth or on the surface of earth. And generally we talk about gravity of earth only. So when we take F is equal to mg and when we take mass to be unit here in SI system, the unit mass will be 1 kg. So let us take mass as 1 kg into what is the value of g. Now unlike this where A can be taken as 1 meter per second square, we cannot take g to be 1 meter per second square. We know the value of g, we have assumed it to be constant on the surface of earth or close to the surface of earth, and its value is taken as 9.8 meter per second square. So we can say from this you can easily define 1 kg weight. What is 1 kg weight? Can you define it? Yes, you should be able to define it. 1 kg weight is the force of gravity acting on a body having mass 1 kg or 1 kilogram. It means it is the weight of a body having mass 1 kg. Because force of gravity acting on a body having mass 1 kg is nothing but its weight. So weight of a body having mass 1 kg is 1 kg weight. Now if from the definition, when you put this F is 1 kg weight, when M is 1 kg and G we know is 9.8 meter per second square, just 9.8 into 1 is 9.8 and write the units together, kg meter per second square. But we know that 1 kg meter per second square is 1 Newton. So instead of kg meter per second square, we can put Newton. So here we get 1 kg weight is 9.8 Newton. Or we can say, in fast, if you have to give answer, you can just say 10, approximately 10 Newton. Okay, so there is a difference here in the definition. This is related to gravity. So weight of a body having mass 1 kg is 1 kg weight, or 1 kg weight is the force of gravity acting on a body having mass 1 kg. Now, next, suppose if we want to define gram weight or gram force, that is the CGS unit of weight or force, then we can, you know the definition, now we can easily define it is a force of gravity acting on a body having mass 1 gram. 1 gram weight is the force of gravity acting on a body having mass 1 gram, or you can say it is the weight of a body having mass 1 gram. So from the definition, if you use this formula and write 1 gram weight for F, mass will be 1 gram, and G value you have to put in the its value in CGS system, in CGS units. What is the value of G? Here it is 9.8 meter per second square in SI. In CGS the units are centimeter per second square. So you need to multiply 9.8 by 100. So you get G is 980 centimeter per second square. Just multiply the magnitude. 980 into 1 is 980 gram centimeter per second square. And as we have seen here, gram centimeter per second square is dyne. So here we have got 1 gram weight is 980 dynes. So I hope you have understood the difference between absolute and gravitational units. Although generally we use absolute units in the sums, in the theory, in the exams we use absolute units only. But in reality, when you are asked your weight, you use the gravitational units. Let me explain you how. I hope this is clear. The definitions of kg weight and gram weight are clear to you, and the conversions are clear between the SI and SI units, absolute SI unit and gravitational SI unit. Similarly, the relation between gravitational CGS unit and absolute CGS unit, you can easily convert. Now dear students, just see here, if the body is having mass 1 kg, its weight is 1 kg weight. If the body is having mass, similarly, if you can try, if the mass of the body is 2 kg, its weight will be 2 kg weight. If the body's mass is 3 kg, its weight will be 3 kg weight. It means although mass and weight are not the similar physical quantities, mass is a scalar, we have seen the differences earlier. Okay, so mass and weight are different physical quantities, but when we talk about the gravitational unit of weight, then mass and the weight, their magnitude, their numerical values are equal. Not the units, their numerical values are equal. It means in the magnitude units are also involved. So we will leave the units, okay, because mass is different, weight is different. The units are different, but check the number. Body having mass 1 kg has weight 1 kg weight. Okay, so actually when you are asked your mass, you should say my mass is 60 kg and your weight should be 60 kg weight or 60 kg force, which is equal to, in numbers, the value is equal to, the numerical value is equal to mass of your body. So whenever you are asked to give your answer for weight, you should always say your mass is whatever the number is there, 50 kg weight or 60 kg weight. Mass is 50 kg and weight is 50 kg weight. Okay, so similarly when we see this CGS here, we know that for a body having mass 1 gram, its weight is 1 gram weight. For a body having mass 30 gram, its weight will be 30 gram weight. So on the spring balances also, generally we say spring balances, we know that we have studied under differences that spring balance measures weight of a body. But when you are asked to find density of a given body in the lab, for density, you know density is mass upon volume. For mass, you use the spring balance only, and although we say that spring balance measures weight. This is because actually spring balance measures weight, but the numerical value of the mass is equal to the numerical value of the weight. So whatever reading you get from spring balance, if you change the units, write the proper units, you can use it for mass also as well as for weight. So we'll see in more depth in the next video, or maybe in future I'll put one video regarding that. Okay, so I hope with this the gravitation part of this chapter is over. When you see the reference books, this gravitation part is divided into two chapters, gravitation and flotation. But when you see the NCERT textbook, this gravitation chapter, whatever we have covered till now, is half part. Okay, and actually this half part is there for this year's syllabus. It has been reduced. The flotation part has been deleted due to corona. Okay, but we'll be doing those topics also, as they are not supposed to be deleted. Those who are going to opt science, they should do it. So with this, I hope that this chapter is clear to you. Thank you, students.